Hi guys, so today we will be solving for the derivative of the function using the limit process. Now to solve for the slope of the tangent line or the derivative of the function, we have here the equation y prime equals the limit of f of x plus delta x minus f of x all over delta x as delta x approaches 0. A substitute equation for that one would be this equation below, wherein it uses the h here as a substitute for delta x. Now, for problem number 1, we have here the function y equals 3x squared plus 2x plus 1. Now, to solve for its derivative or the slope of the tangent line as a function, we can start by solving for f of x plus delta x. And in order for us to solve for this one, just replace all variable x with x plus delta x. I would have here 3 times x plus delta x squared plus 2 times x plus delta x plus 1. Simplifying, I would have here 3 times the expanded form of this binomial here. I would have here x squared plus 2x delta x plus delta x squared. Then followed by this one here. I would distribute 2 to this binomial. I would have 2x plus 2 delta x then plus 1. Next, let's distribute 3 to this equation. I would have here 3x squared plus 6x delta x plus 3 delta x squared plus 2x plus 2 delta x plus 1. Okay, now that we have this function here, let's now solve for its derivative. So I will use here this equation. I would have here y prime equals the limit of f of x plus delta x minus f of x divided by delta x as delta x approaches 0. Let's plug in our functions. I will have here f of x plus delta x, that is 3x squared plus 6x delta x plus 3 delta x squared plus 2x plus 2 delta x plus 1, then minus f of x, and f of x is just our original function, 3x squared plus 2x plus 1, then all over delta x. Let's simplify our function here. I can cancel out terms in the numerator, and if I distribute this one, I would have here a negative 3x squared negative 2x minus 1. Then I would just copy the rest of the terms. I have here 3x squared plus 6x delta x plus 3 delta x squared plus 2x plus 2 delta x plus 1. I can cancel out 3x squared negative 3x squared positive 2x negative 2x positive 1 and negative 1. Then I will divide the simplified form of this one by delta x. So I will be left with 6x delta x plus 3 delta x squared plus 2 delta x divided by delta x. Now, to further simplify this one, I can factor out a delta x in the numerator. I would have here 6x plus 3 delta x plus 2 divided by delta x. I can cancel now this delta x here. So its simplified form would be 6x plus 3 delta x plus 2. And the final step here is to solve for its limit as delta x approaches 0. And to do that, just replace delta x with 0. I would have here 6x plus 3 times 0 plus 2. So this one would be 0. Therefore, its derivative would be equal to 6x plus 2. Let's proceed with problem number 2. For problem number 2, we have here the function y equals 3x cubed minus 2x. Let's solve for its derivative using the limit process. To start, let's solve for f of x plus delta x, and that will be 3 times, replace x with x plus delta x. I would have here x plus delta x cubed minus 2 times x plus delta x. Next, simplify this binomial here, and if we expand this one, I would have here x cubed plus 3x squared delta x plus 3x delta x squared plus delta x cubed. Then for the second term, I would have here, if I distribute negative 2, negative 2x minus 2 delta x. Next step, let's distribute 3 to this equation. I would have 3x cubed plus 9x squared delta x plus 9x delta x squared plus 3 delta x cubed. Then copy negative 2x and negative 2 delta x. Now that we have f of x plus delta x, we can now solve for the derivative, and that would be the limit of f of x plus delta x minus f of x divided by delta x as delta x approaches 0. Let's plug in the functions. 3x cubed plus 9x squared delta x plus 9x delta x squared plus 3 delta x cubed, then minus 2 delta x minus 2x minus 2 delta x, then minus our f of x here, our original function, 3x cubed minus 2x, then all over delta x. Let's simplify. I will just copy the terms here. 3x cubed plus 9x squared delta x plus 9x delta x squared plus 3 delta x cubed minus 2x minus 2 delta x. And for this one, I can distribute the negative sign. I would have here negative 3x cubed plus 2x all over delta x. I can simplify the numerator here. I can cancel out 3x cubed, negative 3x cubed, negative 2x, positive 2x. Its simplified form would be 9x squared delta x plus 9x delta x squared plus 3 delta x cubed minus 2 delta x, then divided by delta x. Next step, let's factor out a delta x in the numerator. I will have here delta x times 9x squared plus 9x delta x plus 3 delta x squared minus 2, then divided by delta x. So this one cancels out. So its simplified form would be 9x squared plus 9x delta x plus 3 delta x squared minus 2. The final step here is to evaluate or solve for its limit as delta x approaches 0. And to do that, I would just have to substitute delta x with 0. So I will have here 0 and 0. So the final answer here, or the derivative here, would be 9x squared minus 2. Let's now solve problem number 3. We have here the function y equals 2 over x. And for this problem, I would use here the second equation wherein it uses h as a substitute for delta x. To start, let's solve for f of x plus h, and that would be 2 over x plus h. And now that we have this function, we can now proceed with the equation for the derivative, and that will be the limit of f of x plus h minus f of x divided by h as h approaches 0. Let's plug in our functions. I would have here 2 over x plus h minus 2 over x, our original function, divided by h. Let's simplify the fractions in the numerator. I can start by multiplying these two here. I would have here 2x, then minus 2 times 2 times x plus h, then divided by the product of the denominators, x times x plus h, then all over h. We have here division of fractions. To simplify this one, just multiply this denominator with the denominator of the numerator. So its simplified form would be 2x minus 2 times x plus h divided by h times x plus h. Let's simplify that further. I can distribute negative 2 from this factor here. I would have 2x minus 2x minus 2h divided by h times x plus h. This one cancels out. We will be left with negative 2h divided by h times x plus h. And also, h here cancels out. So its simplified form would be negative 2 all over x times x plus h. Now the final step here is to solve for its limit as h approaches 0, and that will be negative 2 divided by x times x plus 0. Therefore, its derivative would be equal to negative 2 over x squared. Let's now solve problem number 4. For the fourth problem, we have here the function y equals square root of x. Again, we would use this second equation to solve for its derivative. Let's solve for the function f of x plus h, and this would be equal to the square root of x plus h. Let's now solve for its derivative. This would be limit of f of x plus h minus f of x divided by h as h approaches 0. Plugging in the values, I would have here the square root of x plus h minus square root of x divided by h. To simplify this one, we would need to multiply both the numerator and denominator to the conjugate of the numerator in order for us to remove the radicals. Okay, so I'll multiply this function here by square root of x plus h plus square root of x all over square root of x plus h plus square root of x. Simplifying, in the numerator, I have here difference of squares. Its simplified form would be is to multiply these two functions here, square root of x plus h multiplied by square root of x plus h. That would be simply x plus h. Negative square root of x multiplied by positive square root of x. That would be x. Then divided by uh, h times square root of x plus h plus square root of x. I can simplify this one. I can cancel out x and negative x. I'll be left with h divided by h times square root of x plus h square root of x This one cancels out. So its simplified form would be 1 over square root of x plus h plus square root of x. The final step here is to evaluate the function or solve for its limit as h approaches 0. I would have here 1 over square root of x plus 0 plus square root of x, or simply 1 over square root of x plus square root of x, or the final answer here would be 1 over 2 square root of x.